Hello all. Today we'll be looking at stroke prediction using machine learning. So coming to the research question. The research question is: can machine learning techniques, mainly classification for the selected data set, accurately detect the chance of stroke occurrence on people based on the population characteristics, health features, and lifestyle factors? Our aim here is to try and find out if machine learning techniques like classification predict the risk of stroke in people based on various features that are available in the given data set. So why is this question very important to us? This is important because according to World Health Organization, stroke is the second most cause of deaths. This model will definitely help us predict if people are at risk of stroke based on previous outcomes. So the data set, this data set was basically sourced from Kaggle, which consists around 500 entries, 5,000 entries. I'd like to thank Fedor Soriano for this data set. So the machine learning technique we'll be using for this is classification. Classification, as we know, is a type of supervised learning technique where we predict certain categorical instances based on past outcomes. So classification models are trained to recognize patterns of different features associated with strokes. Once our model is trained, we'll basically predict future outcomes based on the past outcomes. So there were three classification models used, which is random forest, SVM, and gradient boosting. So random forest is a supervised learning model which works for both task like regression and classification. So it basically builds on multiple decision trees where each tree makes a prediction. It then combines all the predictions to give out an outcome. You can go through the pros and cons here. So the next is SVM. SVM basically works by finding the hyperplane which separates data points into different classes while maximizing the margin between classes. Again, this also has some pros and cons. You can go through that. So the next is gradient boosting. So this also works similar to random forest where multiple decision trees are used to give an outcome, but this basically learns from multiple weak models. Again, this model has pros and cons which we can go through. So the data analysis, basically the data set was clean to start with. We only had a few null values for the BMI column. As we can see here, there were 201 null values, and we basically filled up those null values using median BMI value. So the next step, what we did was there were a few So there were a few categorical variables where we one hot encoded them, which basically converts them to binary type, which is ideal for machine learning. We also have counted the number of stroke instances, whether the stroke is 0 or stroke is 1. As we can see, the stroke instance for 0 is very high, and stroke instance where stroke is 1 is very less. So the next thing what we did was oversampling, where we basically upsampled the minority class to make the dataset balanced. So this was done because as instances of stroke occurrence was very less, which is not ideal for the training model. So coming to the next step, we have basically split the training set into training and testing set into 70 and 30%. So the splitting is very important to train the model. Also, we to assess its performance. So now we basically train all the three models. Once we have trained the models, we'll be basically evaluating them on several evaluation metrics, which is accuracy, precision, recall, F1 score. So as we see, we have trained our models here, which is for random classification, SVM classification, and gradient boosting classification. We then evaluate them on both training and test set. We're then plotting confusion matrix, and we're also printing out the classification report for both training and testing set. So as you can see, we have plotted the confusion matrix. As you can see here, the true negatives and true positives for random forest is very high, and it has zero false positives and false negatives, which is very good. It has a perfect score, and SPM performed moderately, and gradient boosting also performed very well. Similarly, in the test set, both random forest and gradient boosting perform well, and SVM again perform moderately. So as we can see the results for random forest train set from the confusion matrix, random forest perform very well, and the other two perform moderately. These are the results for test set, and the next is the ROC curve and the precision recall curve. Again, as we see higher, the area under ROC curve is very high for random forest, which is perfect, and it's moderate for SVM, and it's good for gradient boosting. Again, we can see the results of ROC and the precision recall curves here. We also have plotted the feature importance graph, where we see which feature has very high importance. So as we can see, age played a big role on the stroke rate. It has very high impact, and also the average glucose level, BMI. These three played a big role in the stroke prediction. So basically, to conclude, we have compared three models for the data set, and random forest performed very well, and it has high precision. SVM basically showed moderate performance for the data set, and fell a lot below random forest. Gradient boosting performed very well. It has high precision recall and different scores, but it just fell slightly short with random forest. As we can see, there are some limitations. We already talked about the cons for um, all the three models. So these are the limitations. So to conclude, we comparing all the three models and how they perform both on test and train sets, we can conclude that the random forest is the best choice model when compared to the other two models that we have used. Thank you.